can be used? How can they be modified? Using arithmetic and C. You perform many arithmetic calculations using variables in C. Addition, subtraction, multiplication, square roots, powers, whatnot. So can we do that with pointers? They are basically variables too, right? Let us see. We can perform arithmetic operations on the pointers like addition, subtraction, etc. However, as we know that pointers contain the address, the result of an arithmetic operation performed on the pointer will also be a pointer if the other operand is of type integer. This is an interesting concept here. When you perform an arithmetic calculation using two pointers in C, then the result would actually be an integer. But if you perform a valid arithmetic operation using one pointer and the other integer, then in that case the result would be a pointer. But when you use two pointers and perform a valid arithmetic operation, then the result would be an integer and not a pointer. The result in that case won't be an address anymore. So in pointer from pointer subtraction, the result will be an integer value, as I already said. Following arithmetic operations are possible on the pointer in C language. You can increment a pointer, you can decrement a pointer, you can add two pointers, you can subtract two pointers, and you can compare two pointers. But you cannot perform multiplication and division. Those are not valid operations. How can you multiply two addresses? That seems illogical, right? Think of it that way. What's the meaning of dividing two addresses? It has no basic logic. So they are invalid. You can add two addresses, you can subtract them, but you cannot multiply or divide them. It's very illogical, impractical if you see. Nextly, we see how these are implemented, how these operations are implemented. For example, if you want to increment a pointer, if we increment a pointer by 1, the pointer will start pointing to the immediate next location. This is somewhat different from the general arithmetic, since the value of the pointer will get increased by the size of the data type to which the pointer is pointing. Suppose it is pointing to an integer type, and the integer in that particular architecture has 4 bytes of memory. Then if you increment a pointer by 1 value, then it is actually pointing to the next location, hence the address is incremented by 4 bytes. 4 is the memory of the one integer variable. The address gets updated by 4 values, whereas pointer is actually incremented by 1 value. We can actually traverse in an array by using the increment operation on a pointer, which will keep pointing to every element of the array, perform some operation on that, and update itself in a loop. If you increment a pointer which is pointing to elements of an array, if you increment that 1 by 1 by 1, then subsequently it will point to the next immediate element in the array. It's simple. The usual subscript notation also does that. The loop is implemented, the subscript moves ahead by 1 value each time in the loop. Similarly, if you increment the pointer instead of the subscript, the array elements can also be accessed in that way. The rule to increment the pointer is given as follows. Suppose you want to know the new address. The new address would be the current address plus I into size of the data type. I is the number of times the pointer is updated. Size of data type is the size of the data type of the pointer, be it integer, float or character, and new address is the address you will get after updating the pointer. So basically in a 32-bit architecture, it will be incremented by 2 bytes, whereas in a 64-bit architecture, it will be incremented by 4 bytes. That's basically incrementing a pointer. Similarly, pointers can also be decremented, added or subtraction. We'll look into that in a few seconds. Firstly, we see an example of incrementing a pointer in 64-bit architecture, so it will be updated by 4 bytes. Let us see if it happens that way or not. First of all, an integer variable is declared and assigned the value of 50. Then you declare a pointer and then you make it pointing to the variable given here, and then you print the value. The original address is printed first of all, then the pointer is incremented in the next step. P is equal to P plus 1 increments the pointer by 1 value, and then you print the next address, the updated pointer. Let us look at the output. If you see, the second address, the new address, is actually incremented by 4 values, 4 units. Whereas the pointer was actually updated by 1 unit, the address is actually updated by 4 bytes. Because I had told in 64-bit architecture, the value of pointer would be incremented by 4 bytes. So yes, it happens that way. Nextly, we see how we can traverse an array by using a pointer. First of all, you declare an array. Naturally, you assign the values 1, 2, 3, 4, 5. 5 values are present in the array. And then you declare a pointer of integer type and it points to the array. See, basically, if an integer type pointer is pointing to an array, then it is actually storing the address of the first element of the array, which is the base location. The pointer is not an array here, right? It is actually storing one single value, one single address of any variable, and that's the address of the first element of the array. Keep that in mind. So nextly, we print the elements as follows. We begin a for loop similarly, and then instead of using the usual subscript notation, here the value is given as star of p plus I. So as I said earlier, star is used to print the value of the pointer, and gradually the pointer is actually incremented by I units, and the asterisk sign prints the value of the updated pointers, the values which are stored in the pointers, and that would give the output that way. As you can see, if you print the array elements, the output is given as 1, 2, 3, 4, 5. So it's pretty simple to access the array elements this way. You can avoid using the subscript notation because this is way too easier and it has many users. Nextly, we see how pointers can be added. We can add a value to a pointer variable. The formula of adding pointer addition is given here. The new address would be the current address plus number into size of int data type. Any data type, not exactly int, it can be anything. It's similar to incrementation. The difference here is 2 values are getting added here. Similarly, subtraction is also performed that way. We can subtract a value from the pointer variable. Subtracting any number from a pointer will give an address. The formula of subtracting value from the pointer variable is as follows. New address is the current address minus number into size of data type. Whatever the number you wish to subtract, you need to multiply that with the size of the data type. So if 2 pointers are of the same type, address 2 minus address 1 is the subtraction of basically 2 addresses. That would give the value as an integer. And that integer would be subtraction of the 2 given addresses divided by the size of data type which pointer points. That would be an integer and not an address. So subtracting 2 addresses will actually give an integer, which is the value of the subtraction of 2 addresses divided by the size of the data variable. Now As we already discussed, subtraction, addition, incrementation, decrementation, and comparison are the valid arithmetic operations that can be performed on pointers. Now, given here are some illegal arithmetic operations using pointers. There are various operations which cannot be performed on pointers. Since pointers store address, hence we must ignore the operations which may lead to an illegal address. For example, multiplication. This is the list. You cannot add two addresses. You can add a value to an address but not two addresses. We have seen the syntax for adding a number to an address. But remember, you cannot add two addresses simply. You can subtract them, but you cannot add them. Secondly, you cannot multiply two addresses. That's illegal. You cannot find the modulo of two addresses. You cannot divide two addresses. Performing logic operations on addresses is also illogical. You cannot perform bit operations, the AND operation, the OR operation, the NOR. No, you cannot perform them on addresses. You can perform them on data variables but not in addresses. It's illogical. So I hope that's clear. You can basically perform addition, subtraction, incrementation, decrementation. But you cannot add two addresses. You can subtract them, you cannot add them. And subtracting two addresses gives an integer value. So now let us see what is an array of pointers. There may be a situation when we want to maintain an array which can store pointers to an int or character or any other data type variable. Following is the declaration of an array of pointers to an integer. We have already looked at a similar example. This is how you can declare an array of pointers. In start pointer, max is the size of the array. It declares pointer as an array of max integer pointers. Suppose max is 10, then there are 10 integer pointers. Thus, each element in pointer holds a pointer to an integer variable. You can also use an array of pointers to characters to store a list of strings. That would be the last topic in our discussion. We'll see that later. Let us see. So see pointer to pointer. A pointer to a pointer is a form of multiple indirection or a chain of pointers. Normally, a pointer contains the address of a variable. When we define a pointer to a pointer, the first pointer contains the address of the second pointer, which points to the location that contains the actual value. C also has pointers to pointers. You can store the address of a pointer which is actually pointing to a different variable. It's very simple. Pointers basically store the addresses of integers or characters. Now you can also have another pointer which is pointing to a pointer, that particular pointer which is pointing to a variable. So it is called a pointer to a pointer because it is pointing to a pointer which is pointing to another variable. This is the pictorial representation. As you can see, the value is being pointed by a pointer which is present at the middle, and that pointer is being pointed by another pointer which stores the address of that pointer. So a variable that is a pointer to a pointer must be declared as such. This is done by placing an additional asterisk in front of its name. Now pointers are usually declared by placing an asterisk sign. Similarly, if you want to declare a pointer to a pointer, you add another asterisk sign before that. So you use two indirection operators. For example, the following declaration declares a pointer to a pointer of type int star var. So in this case, it is actually a pointer to a pointer. When a target value is indirectly pointed by a pointer to a pointer, accessing that value requires that the asterisk operator is applied twice. Simple. You just need to place another asterisk operator. This is the program that will illustrate the use of pointer to a pointer. So first of all, a normal integer variable is declared, then a pointer is declared that points to that variable, which is ptr. Then you declare another pointer which is pointing to the ptr pointer. So basically it's a pointer to a pointer, so you use two asterisk signs and it starts pptr. Then there is assigned the value of 3000, pointer stores the address of that variable, and pptr stores the address of that pointer. So basically if you print the values, all would be the same regardless of the variable you use, because the star ultimately gives the address of the value of the pointer. So the output would be the same. In all the three statements for printing the output will give the same result, which is 3000, which is the value of the integer variable. I hope I have illustrated the use of pointer to a pointer. Nextly, we see how pointers can be passed to functions in C. So this is the program. I hope it's clear. First of all, this is the program which actually returns the average of the numbers using another function. Let us see. First of all, the getAverage function is declared. Then we declare the main function. We go on with that. An array is declared of balance and elements are assigned the respective values. Then the average is assigned the value the getAverage function returns. But in this case, if you see, an array is passed in the form of a pointer. If you look at the parameter list of the getAverage function, then it's int star ar and not ar with subscripts. So basically you are passing a pointer here, pointer to the array. And if you perform the operation on the pointer array, then it would yield the same result that would have, you have got with passing the array. So if you see, the result is still the same, but in this case, instead of passing the array in the usual way, the pointer is passed on, and that would give the average of the array elements as mentioned here in yellow. Nextly, you see what are the basic differences between pointers and arrays. We saw here that an array can be passed in the form of a pointer. So let's differentiate between the two. Most of the time, pointer and array actually can accessed and treated in the same way. But the major exceptions are the size of operator. Size of in case of array returns the amount of memory used by all elements in the array. But size of in case of pointer only returns the amount of memory used by the pointer variable itself. I have already told the size of pointer variable never changes regardless of the value it is pointing to. So if you use size of on an array, then it will return the size of the entire array, but if you use it on the pointer, then it will return just the size of the pointer. Nextly, we see the AND operator, the ampersand. AND array is an ally for AND array of first element 0 and returns the address of the first element of the array, the base location, whereas ampersand pointer returns the address of the pointer. I hope that's clear. AND array returns the address of the first location of the array, the base element, whereas the AND pointer will return the address of the pointer naturally, not the array. Thirdly, a string literal initialization of a character array. How does that differ? If you use the array notation, char array is equal to ABC, sets the first 4 elements in the array to ABC and the last one would be null. But if you assign char star pointer as ABC, then it sets the pointer to the address of the ABC string, which may be stored in read-only memory and thus unchangeable. You cannot alter them in that case. Pointer variable can be assigned a value, whereas any array variable cannot be. Right? Array variable points to all the elements of the array. It's not a single element, but pointer is a single element, so it can be stored that way. It can be assigned any random value you want. Nextly, we see how we can return pointers from functions. Now C also allows to return a pointer from a function. We have already passed pointers, operated on them. Now let us see how we can return them. To do so, you have to declare a function returning a pointer. See, in the definition of the function, you need to add asterisk sign. Wherever you have to declare pointers, you need to add that asterisk symbol. So basically int star, instead of simply int function, you just have to add an asterisk sign. Second point to remember is that it is not a good idea to return the address of a local variable outside the function. So better if you would have to define the local variable as static variable. You must not know what's a static variable, but we'll see that later on. But as of now, keep in mind that whenever you need to return a pointer from a function, forget not to declare that variable as static. So this is actually a program that would generate 10 random numbers and return them using an array name which represents a pointer. So this is the program to generate 10 random numbers. The usual syntax is followed. The getRandom function is used, and then the seed is set, which is the requirements of generating 10 random numbers. And see, in two ways the numbers are actually printed. Once inside that function and another time inside the main. But if you will see in the output, both the cases would yield the same 10 random numbers. It doesn't matter if they are printed inside that or they are returned from the function to the main function. The values which are returned from that in the getRandom function are actually the same as the ones which are present inside the getRandom functions. So if you look at the output, both the cases are same. In the second case, the main function is implemented, whereas in the first case, the values are printed right inside the getRandom function. Both are basically the same. So nextly, let us see what are dangling pointers. Now the most common bugs related to pointers and memory management is dangling or while pointers. Sometimes the programmer fails to initialize the pointer with a valid address. Then this type of initialized pointer is known as a dangling pointer in C. Dangling pointers occur at the time of object destruction when the object is either deleted or deallocated from memory without modifying the value of the pointer. In this case, the pointer is actually pointing to the memory which is deallocated. The location which the pointer was once pointing to has been deleted. So it's basically pointing to nothing. The thing it was pointing to has been deallocated. It is not present there anymore. So in that case, the pointer would be called a dangling pointer. The dangling pointer can point to the memory which contains either the program code or code of the operating system. This picture will illustrate a dangling pointer. The first two cases are valid. They are usual pointers. But if we see, pointer 3 is actually a dangling pointer. Pointer 1 and 2 are the pointers that point to allocated objects, object 1 and object 2. But pointer 3 is a dangling pointer as it points to the deallocated object. If we assign the value to this pointer, then it actually overwrites the value of the program code or operating system instructions. In such cases, the program will show undesirable result as the code has been modified. It may even crash. The memory is reallocated to some other process, then we are actually dereferencing the dangling pointer, which may cause segmentation faults. So you must be very careful that there are no dangling pointers in your program. Nextly, we become familiar with the concept of pointers and const. Const is constant. Pointers can be used to access a variable by its address, and this address may include modifying the value pointed. But it is also possible to declare pointers that can access the pointed value to read it, but not to modify it. For this, it is enough with qualifying the type pointed to by the pointer as constant. Read that again. So if integers are declared as x and y, and you declare a pointer of const type, which is constant, and then you assign it the value of y, it is fixed to that. If you want to print the value of that, it's okay. If you want to assign x as the value of pointer, it is okay. But you cannot initialize the value of pointer as x. It is already constantly fixed at the value of y. You cannot alter it anymore. That's fixed to y. You cannot assign it the value of x. So here p actually points to a variable, but points to it in a constant qualified manner, meaning that it can read the value pointed, but it cannot modify it. It's read only. You can access the value, but you cannot modify it. Note also that the expression and y is of type int, but this is assigned to a pointer of type constant int. This is allowed. A pointer to non-constant can be implicitly converted to a pointer of type constant, but not vice versa. So as a safety measure, pointers to constant are not implicitly convertible to pointers to non-constant. Non-constant can be modified to constant, but constant values cannot be modified to non-constant. That's for safety measures. Otherwise, anyone can change your code. So one of the usual cases of pointers to constant elements is as function parameters. A function that takes a pointer to non-constant as parameter can modify the value passed as argument, but while a function that takes a pointer to constant as parameter cannot. A function that takes a value as constant, which is predefined as constant, cannot modify that. It can access that, but it cannot modify that. Keep that in mind. So lastly, we look at pointers and string literals. How can pointers be used to access strings? So as pointed earlier, string literals are arrays containing null terminated character sequences. String literals have been used to directly insert into cout, right? We have seen that in the previous video, to initialize strings and to initialize arrays of characters. But they can also be accessed directly. String literals are arrays of the proper array type to contain all its characters plus the terminating null character, with each of the elements being of type constant, so they can never be modified. Constant char star foo is assigned hello. This declares an array with the literal representation for hello, and then a pointer to its first element is assigned. If we imagine that hello is stored at the memory location that starts at address 1702 in the given figure, then this declaration can be represented as given in the figure. That's how you can use pointers to access string literals. So I hope you have become familiar with the concept of pointers, because they are really very crucial for learning to program. Be thorough with it, practice questions. I hope you liked our video. Thanks a lot.